Donut Lab just released their third-party validation test for their solid-state battery. And while not as big of a bombshell as their second, this one still has some pretty deep insight. Plus, we have 3 tests now, so there's a lot of numbers, and you know we dug into it. They tested self-discharge. Not what I was hoping for. I really wanted to see a cold weather test, but they did self-discharge and found that 97.7% of the charge remained after 10 days. But the most important number of the report is one Donut didn't mention in their video. And when you stack it against the first 2 tests, it tells a pretty cool story. So in this video, we're going to break down test number 3, the self-discharge test, and compare it to what we know so far from test 1 and 2, and give you a fuller picture of what we know and what we don't. I'm Ricky, and this is 2-Bit Vinci. This video is brought to you by Mammoth. VTT tested cell DL1, a different cell from the first 2 tests. They charged it to approximately 50% state of charge and then left it on a shelf for 10 full days. No climate chamber, just room temperature. The tester recorded voltage every 10 seconds, 86,400 data points. After 10 days, they discharged it. 13.029 amp hours came back out of the 13.335 they put in. That's 97.7% retention. But before we talk about what that means, Donut chose this test for a specific reason. They said it explicitly, to prove that this isn't a supercapacitor. So since that was literally the point of this test, let's see how it stacks up. Here is real supercapacitor self-discharge curve data that we saw published from Vinci. And you can tell the clear supercapacitor pattern here, that downward slope. The voltage just kind of bleeds away. Over 10 days, supercapacitors can lose 10 to 50% of their charge. Some lose half their voltage in just 6 days. Now here's the donut cell. Sharp drop in the first hour, 103 millivolts. That's normal IR relaxation and charge redistribution. But from hour 10 to 240, it's pretty flat. Only 12 millivolts are lost over 230 hours. That's 0.05 millivolts per hour. Supercapacitor drops around 9 millivolts per hour, about 180 times faster. But what Donut didn't do is ask the harder question. If it is a battery, how does it actually compare to other batteries? So we did. We pulled published self-discharge data for every major company and chemistry we could find. NMC lithium ion, the chemistry that we kind of suspected this might be after test 1, self-discharges 1 to 3% per month. Over 10 days, at 50% state of charge, a healthy, mature NMC cell typically retains around 99% or better. LFP, lithium iron phosphate, and NCA are around the same. And sodium ion at room temperature, we found some published data, less obviously, but it's also kind of in that ballpark. Now look at Donut's data, 2.3% lost in 10 days, compared to the 1% that we were seeing from most other papers for mature cells. But here's the thing, slightly worse self-discharge is honestly what you'd probably expect from a prototype cell. These cells aren't rolling off of a BYD or Panasonic assembly line. 5% tells you that these are probably hand-built or low-volume prototypes, not production-grade units. But again, not a red flag for a company at this stage of validation. But exceptional, they are not. Every chemistry on the table that we compare this to, traditional batteries of today, all perform better. Fun fact, the top comment on the Donut video so far on test 3 is, next week, we test the pouch color to see if it is in fact silver. I think that captures where people are at right about now. Now, here's what caught our attention. Buried on page 10 of the VTT report, the voltage data at 50% state of charge. Right after charging, the cell reads 3.861 volts. As it relaxes to equilibrium, it settles to 3.745. That's the real fingerprint. Donut didn't mention either number, but if you know batteries, this is one of the most diagnostic measurements there is. High nickel NMC sits around 3.65 to 3.75 at 50% state of charge. LFP, around 3.3. Standard sodium ion batteries are 2.8 to 3.2. Now, as we covered in detail in our last video, this voltage doesn't automatically mean that the cell is NMC or lithium, because there is a class of high voltage sodium ion layered oxide cathode that produces nearly identical voltage profiles. So we can't tell them apart by voltage alone. Our research really helps us bring these stories to life. And when it comes to research, there's a new tool that's really been helping out our team. This is Mammoth. And instead of paying $20 a month for Gemini, ChatGPT, and Claude, Mammoth is a platform that gives you access to all the best models in one place. Mammoth breaks out the best models for various tasks based on text, image, research, or reasoning. Their interface is clean and familiar, but check this out. When I was researching for this script, I used Perplexity, but I can easily re-prompt my request and pick a new model, like Claude Opus 4.6 that just came out. For images, Nano Banana is really good, but I can easily compare to others like Stable Diffusion with the same prompt. Create custom mammoths with unique system prompts for the things you do most. I have a mammoth for custom system prompts for research, and another for designing thumbnails. You're probably familiar with user prompts, the part we type in chat. It's the what. But the system prompt is the why and how. It tells the AI how to act and think, like be my lead researcher or you're my chief software architect. And if you like command line tools, there's Mammoth Code. It installs just like Codex or Cloud Code right in your terminal. And they offer API keys if you're building an app or use services that need API keys. So however you use AI, level up your game. Bring the power of all the latest and greatest models in one place using Mammoth AI. Learn more and get started today using our links in the description. Huge thanks to Mammoth and you. Now back to the show. But here's what we can say now that we have had data from all three cells. Some commenters have suggested that maybe Donut is swapping in different chemistries for different tests, right? Using a cell really good at fast charging and then a different chemistry for high temperature testing. And that was something I actually thought about and we couldn't really disprove. But I think we can disprove that notion now. Looking at the voltage data, test 1, the charge and discharge curves trace the same profile. Test 2, the discharge plateaued 80 degrees, same shape. And now test 3, 3.74 volts at half charge after 10 days. 3 different cells with 3 different testing methodologies applied, but they have the same electrochemical fingerprint every single time. So whatever this chemistry is, maybe it is a really new exotic lithium, maybe a sodium ion, whatever it is, we can say that it's the same across all 3 cells. So this isn't a shell game where they're using different cells for different tests to kind of rig the system. The consistency is telling. So if the voltage keeps matching conventional chemistries, NMC or high voltage sodium ion, why not just call it one of those and move on? Well, it's because, again, I go back to test 2, my favorite of all the tests. DMC, one of the most common electrolyte solvents, boils at 90 degrees. Flammable vapors, oxygen in the air, combined with extreme heat is just a recipe for a battery fire. But DL2 didn't catch fire, didn't melt down. And VTT charged the cell back up and it still accepted charge. That might be the one result across all 3 tests that's genuinely hard to explain with a standard liquid electrolyte cell. Something about what's inside is different. One commenter named Stefan just put it perfectly. None of Donut Labs' 4 headline claims, solid state, no lithium, 400 watt hours per kilogram, and 100,000 charge cycles, have been tested. The test series have been a structure of marketing campaigns rather than technical validation. Now, I will say, I've been fascinated by this whole saga, and test 2 was genuinely amazing. I think test 3 was a bit of a step back, if I'm honest, but they have claimed that there will be another test next week, and everyone's allowed a dud. If you're watching a TV show and one episode's not great, well, the next one better be, or you might stop watching, right? I kind of feel the same way here at this point. So I actually analyzed the top comments from all 3 videos, including ours, Donut Labs videos, all of it. I put it all together, and the number one most commonly held comment idea is, where's the energy density and the weight testing? And that fact that it's missing. It is still missing. We don't know how much the cell weighed. It would have been super easy to have identified that. Number 2 is the drip feed pacing frustration, meaning people want more information altogether. I actually forgave that in the second test because the second test was so compelling. This third test was not. This could have just been an addendum to test 1 or 2. I don't think it had enough merit to stand on its own. Number 3 is cycle life degradation concerns, meaning how do you ensure that you can actually meet the 100,000 cycles? It's a very hard test to nail, and there's no availability on that just yet. Number 4 is that it's just a regular NMC lithium-ion battery. Number 5 is that they use different cells in each test. I think we can say with a fair bit of certainty that that probably isn't true now. Number 6 is the desire for cold temperature performance. That is something I really wanted to see in test 3. We didn't get it, maybe soon. Number 7 is the supercapacitor hypothesis, right? I brought this up because this is why they're doing this, I think. They've probably debunked that at this point. Number 8 is send some batteries to independent testers. So there were quite a few comments, about 20 in total, saying send it to like even YouTubers like us or Ryan from Zeroth for independent testing. I don't think they're going to do that. I think it'd be too dangerous once you let it out in the wild to make sure that you don't lose your secret sauce. Finally, number 9 is VTT is a lab, not an auditor, meaning remember VTT is working at Donut's behalf to perform tests that they want. They're not trying to debunk or prove or disprove anything. Finally, number 10 is the round trip efficiency and some of the Coulombic efficiency math and stuff. But anyways, we've We're trying here. We're trying to get as much information together as we can because I think honestly the data is pretty light with this one. Finally, I'll leave you with this. While Donut is kind of trickling the information very slowly, there's some serious battery breakthroughs happening. BYD announced very recently their Blade 2 battery, right? 8C fast charging in cars, shipping now. Cars that cost like $17,000. High scale, mass production ready today. And then there's CATL's Naxtra sodium ion batteries, which are genuinely lithium free. They're sodium ion based, verified. But the drawback is that they're only about 175 watt hours per kilogram in terms of energy density. But again, shipping in real vehicles right now. Sound off in the comments below what you would want to see next. Some common comments I've seen is like a nail penetration test, like some way to verify that this chemistry is safer, solid state, non-liquid electrolyte, things like that. Low temperature testing, I think, would be very telling. Again, it's a chemistry validation type of test. You can see a lot about ion transfer and everything else by doing low temperature testing. And I'd love to see that. But until next week, thanks so much for watching. Hopefully test 4 is good. Honestly, if it is as lightweight as this one was, we might not even cover it, maybe just a community post. But we shall see. Let's keep the optimism going. I'd love to know what you think. Is this getting old at this point? Are you still excited or waiting for new news to pop? Sound off in the comments below. I'm Vinci. Thanks so much for watching.